we talk about some equations. We talk about the equations of motion. Right. Now we talk about the equations of motion. Now these are some equations of motion which we use generally in the case of kinematics. Right. So the basic equations of motion in the case of kinematics, the four basic equations. The first one, V equal to U plus AT, S equal to UT plus half AT square, V square minus U square equal to 2AS, Sn equal to U plus A into N minus half. Right. Now these are four different equations of motion which we will be using in the case of kinematics. Right. Basically, when you are preparing for RRB examination, you get number of questions which are based on these particular things, on these particular formulas. But as long as you are preparing for SSC, right, the chance for asking a particular problem based on these questions is very, very less. Right. SI constables, there is a chance for constables or SI, there is a chance that a problem may be asked even on these particular things. Right. But basically, the first three are very much important. For the competition examination point of view, the first three are very much important. V equal to U plus AT, S equal to UT plus half AT square, and V square minus U square equal to 2AS. Now based on this particular equations of motion, we talk about how an object is moving from point A to point B. Right? Those two particular points, suppose that I'm having a point A here, point B here. Between these two particular points, the object is moving. The object, when the object is at the point A, the object may be at rest. When the object is at the point B, the object may be in motion. Right? At the same time, the object may be moving in a vertical plane like this. You are talking about an object which is moving from point A to point B. You are from this particular point to this particular point, and then again coming back. So for all the different types of motion, we using these particular equations. V equal to U plus AT, S equal to UT plus half AT square, V square minus U square equal to 2AS, and Sn equal to U plus A into N minus half. These are the four important equations of motion which we need to focus on this one. Right? Then, now suppose that when you're talking about, first I'll talk about one object called as vertically projected object. First we'll talk about vertically projected object. So what do you mean by the term vertically projected? Now here I have got an object which is present at the point A. Right? We are having a object at the point A. Now this particular object which is present at the point A, I am throwing this particular object in the upward direction like this. When you throw this object in the upward direction, it starts rising upwards. It starts rising upwards. But after reaching a certain height, the object has to move backwards, has to return to the starting point. This is the case. Now when the object is moving from point A to point B, again from point B to point C, what are the changes the velocity of the object is undergoing? That's what we see in the case of vertically projected. Now when you're projecting the object in the upward direction at this particular point, at the point A, the object will have got some velocity which you call it as the initial velocity, represented by the letter U. The moment the object is rising upwards, the velocity of the object continues as the object height is increasing. As the object height is increasing, the velocity of the object continuously it decreases, because the object is under gravity. The object is under gravity, as a result of which, as with respect to height, as the height of the object is increasing continuously, the velocity of the object continuously decreases, and at one particular point, this particular point which you are calling it as a final point, at this particular point, the final velocity V equal to 0. At the maximum point, V equal to 0. Then again, the object is again coming back. When the object is coming back in the reverse journey, this is the starting point. Right? At the starting point, again the object is having certain amount of velocity. Right? Sorry. At the starting point, the object is just behaving as a freely falling object. At the starting point, the object is again simply behaving as a freely falling object. For all the freely falling objects, the velocity of the object is always taken to be equal to 0. Then, as the object is continuously moving in the downward direction, the velocity of the object continuously increases. The velocity of the object continuously increases. Just before it touches the ground, the velocity of the object is supposed to be maximum, right? So, in the case of a vertically projected object, the moment the object is released from the hand, from the surface, it is having maximum velocity. And just before it touches the ground, again it has got maximum velocity. In simple terms, we say that in the case of a vertically projected object, the initial velocity and final velocity both will be the same. But wherein at the maximum point, this is the case of starting point. At the starting point, initial velocity and final velocity both will be the same. But wherein at the maximum point, at the maximum height, at that particular point, the value of u and the value of v will be equal to 0. V is for what? The first case. When you're throwing the object in the upward direction, u value will become 0. And the moment the object is starting the downward direction, u value is equal to 0 because it is acting as a freely falling object. So for all the freely falling objects, u equal to 0. For a vertically projected object, v equal to 0. So in the case of a vertically projected object, at the starting point, the value of u and the value of v is always taken to be, it will be always equal, right? And at the same time, for a vertically projected object, the value of v equal to 0, and for a freely falling object, the value of u equal to 0. Then at the same time, when you're talking about the case of your vertically projected objects, right, the value of u is equal to 0 the starting at the starting point for the case of freely falling object, and the value of v equal to 0 at the maximum point for a vertically projected object. At the same time here, for upwards projected object, when the object is moving in the upward direction, the value of g is taken to be equal to negative. And when the object is moving in downward direction, the value of g is taken to be equal to positive. Here in this particular case, it is taken to be equal to negative because the object is moving against gravity. That is the reason why you are taking it as negative. And here in this particular case, when the object is moving in the downward direction, you are taking it as negative because the object is moving in the direction of gravity. That is the reason why here g is taken to be positive. When the object is projected upwards, the value of g is negative. When the object is freely falling downwards, g is always positive, right? A quick revamp of this one. For all the vertically projected objects, whenever an object is projected upwards, at this particular point, it is having the maximum point. For a vertically projected object, at the starting point, it has got the maximum amount of velocity. And as the height of the object continuously increases, at the maximum point, velocity will be equal to 0. Right? Now, in the reverse case, when the object is moving in the downward direction, for a freely falling object, the value of u is always equal to 0. And when the object is moving in the downward direction, velocity of the object continuously increases, and just before it touches the ground, the velocity of the object will be maximum. So for the case of a vertically projected object, initial velocity and final velocity both will be equal at the starting point, right? At the same time, for an object which is projected upwards, the value of g is negative, and for a downward freely falling object, the value of g is always taken to be equal to positive, right? Then moving on to the next one, that is a projectile. So when talking about the case of a particular object which you are calling it as projectile, what is projectile? So here we'll see one slide, right? Now this is the case of an object. Now the earlier case, when you're talking about a vertical projected object, you're talking about an object which is projected upwards like this. The angle between the vertical projected object and the surface is something equal to 90 degrees. Is something equal to 90 degrees. Sure. Right. Now here, first your object throwing with the angle between, this is the case of an object which is projected upwards like this. When you measure the angle between the vertical projected object and the surface, the angle is something equal to 90 degrees. Right? But here in this particular case, we are not throwing an object exactly at 90 degrees. We are throwing an object at an angle something which is not equal to 90 degrees. Which is not equal to 90 degrees. Which means the object is projected somewhere like this. If this is the x-axis and this is the y-axis, the object is projected something like this. So whenever you are throwing an object in this particular path, here the angle is not equal to 90. Or else, suppose that even if the object is moving like this, again the angle is not equal to 90. So whenever an object is projected at an angle other than 90 degrees, that particular object is what you call it as projectile. Right? At the same time, the path that is followed, this particular path that is followed by the object is known as a parabolic path. All these particular projectiles, right, generally they follow a parabolic path, because there in that particular case, the angle of projection is not equal to 90 degrees. It will be less than 90 degrees. So here, when you're talking about the case of these particular projectiles, each and every particular projectile has got two different types of velocities. One is the horizontal velocity, the other one is vertical velocity. Now we'll see what are that. Right. Now here in this particular case, the moment the object is projected, from this particular point, the height of the object is continuously increasing. The moment the object reaches this particular point, at this particular point the object is having certain amount of horizontal velocity represented by the letter ux, and at the same time it is also having a vertical velocity which is given by uy. Right? Since the object is having both the types of velocities, the horizontal as well as the vertical types of velocities, the object is moving in this particular path. Right? Since it is having vertical velocity, the height is increasing. Since it is having horizontal velocity, the object is covering some distance on the x-axis. Now when it reaches this particular point, at this point again it has got ux, at the same time again it is having uy, which means it is having horizontal velocity as well as vertical velocity. Now at this particular point, the vertical velocity uy is equal to 0. That is the reason why the object is not still further rising up. But since it is having certain amount of horizontal velocity, the object is trying to cover some distance on the x-axis. At this particular point, again you are having certain amount of horizontal velocity, at the same time certain amount of uy, ux as well as uy. Right? And just before it touches the ground, or else at this particular point, the value of ux, horizontal velocity, is equal to 0. Right? That is the reason why there in that particular case the object is still not moving forward, but it is falling downwards because of gravity at this particular point. So here in this particular case, whenever an object is projected at an angle other than 90 degrees, it possesses two different types of velocities. One is horizontal one, other one is vertical velocity. At the maximum point, at this particular point, right, at this particular point, the vertical component will be equal to 0. That is the reason why the object is not still further rising up, but it is moving under gravity. Right? So this is about projectiles. Now we're talking about the case of examples for projectiles. Right? So keeping in view the SSC examination point of view, generally we are expecting some questions or projectiles examples. Right? The motion of a bomb that is dropped from an aeroplane. Now suppose that maybe everyone you might have seen the case of your fighter planes. Suppose that I'm talking about a fighter plane like this, and this is the target. This is a target. Now when you want to bomb the target, this particular fighter plane has to release the bomb. This particular fighter plane has to release a bomb through certain angles so that it reaches the target. Right? Now this particular path, the bomb that is released from this particular fighter plane, it is following a parabolic path like this. Right? Now suppose that instead of that one, suppose that the target is here. At the same time, exactly above the target you are having a fighter plane. The moment this particular fighter plane releases a bomb, this particular bomb, the moment it is released, since it possesses certain amount of horizontal velocity, it starts moving in the horizontal direction like this, as a result of which here there is an absolute chance that the target will be missed for sure. But wherein when you are releasing the bomb well before the target, this is a target. When you are releasing the bomb just well before the target, then in that particular case, there is a chance that the target must be hit compulsorily. So that is the reason why, see, where all these particular fighter planes, they release a bomb well before the target. And this particular path that is followed by a bomb that is dropped is always a parabolic path. It is simply, it's an example for a projectile. At the same time, we talk about a bullet that is fired from a gun. Right? Whenever you are firing a bullet, the moment the bullet comes out from this particular rifle or a gun, it starts following a path like this. Every particular gun, every particular rifle has got certain amount of range. So beyond that, the impact will be reduced. Right? So there in that case, every particular bullet that is coming out from a gun or a rifle, it starts moving in this particular path, which you are calling it as a parabolic path. Or else at the same time, suppose that you talk about an object which you are throwing from a particular point, sitting at one particular place, or else when you are moving in a bus or a car, an object which is thrown from a moving bus always follows a parabolic path. Right? An object that is thrown from a moving bus or a moving vehicle, again it falls out in this particular way. You might have experienced this number of times. Whenever you are traveling through bus or when you are traveling through train, after finishing your thumbs up bottle or coke bottle, you just throw it out. So when you're throwing that particular bottle outside, it always follows a parabolic path. At the same time, the motion of a missile or a rocket which is burnt out is again a parabolic path. Now all these are the examples for parabola. So yes, the last class or the last time we discussed, right, I told you that SSA examination point of view, or else SI or any particular competitive examination that we are preparing, we need to focus on the applications as well as the concepts. So for each and everything, whether you're talking about the case of displacement, we have seen some examples, right? So in the case of displacement, we have seen that when you are moving in a circular path, what is displacement? When you are moving in a semicircular path, what is displacement? At the same time, the displacement of a pendulum. In all these are nothing but the applications or the examples. At the same time, even for the case of projectiles, we are seeing certain number of examples. So which one is following a parabolic path? Applications or the examples are very much important, right? So this is about projectiles. Right? Kinematics. The next class will start about the Newton's laws of motion. Right, and then we'll move on with that. Newton's laws of motion, we'll talk about work, power, energy, at the same time friction, and so on. Right, thank you.